So in this lesson, we are going to cover content from section 1.2, and that's going to cover three major topics. We're going to talk about categorizing data. We're going to talk about what sampling is and different methods for that. And then we're also going to talk about variation in data and sampling. We're going to start off by talking about how to categorize data. And it's really important that you know how to categorize data, because when you're trying to do some research, depending on the kind of data you have, there are different statistical procedures for different kinds of data. And then you also have different kinds of charts and graphs that you might want to use depending on the type of data. So first off, I want to kind of give you an overview of what this is going to look like. So when we look at any data, I'll just label it as all data. All data can be broken down into two categories. We have qualitative data, and then we have quantitative data. Now, the quantitative data can then also additionally be broken down into two categories. So quantitative data can be broken down into what's called discrete or continuous. All right, so now let's talk about the difference between the qualitative and the quantitative. So qualitative and categorical data are the same thing. It's just two different ways of saying it. So if you see that in another textbook, you'll know what they're referring to. Okay, so the difference between qualitative and quantitative is that quantitative deal with values that are measured and counted. So I'll put that under here. Values that are measured or counted. And qualitative data, as we already kind of talked about, is data that you would put in categories. Let me write it like this. There are special cases where qualitative data are actual numbers. However, the reason that they're in that category of qualitative data is because they're typically not numbers that you would use for arithmetic. I wouldn't want to take the average of it or subtract and find the difference. These are still numbers, but they're numbers that are used to categorize things. So an example of qualitative data that are actually numbers is maybe like phone numbers. I wouldn't want to do arithmetic with phone numbers. That's not what phone numbers are for. If I did arithmetic with phone numbers, it wouldn't make any sense. It wouldn't have any kind of meaning. But those phone numbers are like an identification. It's a label that goes with me. My phone number is attached to me. Another example might be a license number or a social security number. Or another example might be the numbers on the back of soccer jerseys. Right? When we look at people's soccer jerseys or hockey jerseys or whatever, and they got those numbers on it, that's there to label them so that we can identify who they are. We're not going to do arithmetic with them. So be careful of that. Most of the time, numbers are going to be quantitative data, but occasionally you get a special case where you have numbers, but it's used still as labeling something. Okay, now the difference between quantitative discrete and quantitative continuous is the difference between being able to count it or not. If you can count the data, then it would be considered discrete. If you have something that you can't count, then that would be continuous. So an example of something that is continuous would be when you measure something, for example, someone's height. Okay, so you could say someone is 5.5 feet. You can say someone is 5.6 feet. And then you can even find a number in between there. If you want something between 5.5 and 5.6, you can say 5.55 feet, right? So there's so many different ways to state heights. If I find two numbers, I can find an infinite number of values between those two numbers, because no matter what number you give me, I can add on another digit and throw it between that number and another number. So it's impossible to count things like that. Now, things that you can count is considered discrete. Like if I was counting the number of cars that went by in the next 20 minutes because I was trying to figure out what the traffic was like. There could be a lot of cars that go by and it might take a long time, but I can count them. All right, so anything that's considered countable would be discrete, and anything that's not countable would be continuous. So I want to make mention some examples of things that you can't count are things that you would measure, like weight, height, length. Things like that would be really, really hard to count because you have an infinite number of digits in between each of your values on your measuring tool. So that would be impossible to count. Okay, so let's go through an example. Now that we've gotten through the difference between qualitative and quantitative, let's go through some examples here. In each of these examples, we have to describe the data. Okay, let's look at example 1. There are multiple parts to example 1, and for each one, we're going to describe the data using the terms that we just learned. So in part A, it says the data are the number of books students carry in their backpacks. You're going to sample 5 students. 2 of the students carry 3 books, 1 student carries 4 books, another student carries 2 books, and 1 student carries 1 book. Now I can count the number of books in their backpack. So that means that this is going to be a quantitative. It's quantitative because I'm counting or measuring it, okay? And then we're going to break that into specifically discrete. So when you have a quantitative variable, it can be discrete or continuous. This one's discrete because I can count the books. Okay, part B says the data are the weights of the backpacks with the books in them. So you sample the same 5 students. If you measure the weight of their backpacks in pounds, we get 6.2, 7, 6.8, 9.1, and 4.3. So now we're taking those same backpacks, and instead of counting the books that are in them, we're weighing them. We're going to narrow it down to continuous rather than discrete because we are talking about something that we're measuring. We are weighing the backpacks and determining what they are in pounds. And when you're doing weight, you can have so many different values. There's an infinite number of values. Okay, the next example, part C. You go to the supermarket and purchase 3 cans of soup, 19 ounces of tomato bisque, 14.1 ounces of lentil soup, and 19 ounces of Italian wedding soup. Then you also get 2 packages of nuts, 4 different kinds of vegetables, and 2 desserts. Now, it doesn't tell me what we are collecting. It says that we went to the supermarket and here are all these things that we picked up, but it doesn't say what we are collecting, what data. So the question is, are we collecting the weight? So let's put this down, the weights. Are we collecting, let's say, the length of the package? Or the item? Are we figuring out what the categories are for the different food groups? Okay, is it soup? Is it dessert? Is it vegetables? These are different categories in here of the food that she's getting. Let's see. What else could it be? We can do the brand names. That would be something. So these are all options. It doesn't specifically tell us what we're collecting. So we're just going to do a bunch of it, which I think is what the author had intended when he wrote this question, for us to consider what the possibilities are, even though it's not given. Okay, so for weights, we know, because we talked about it before, anything that you measure, including weights, distance, length, height, anything like that, that's going to be quantitative because we're measuring something. And then it's going to be continuous because it's not countable. So I'm going to label this as QN for quantitative, and then CON for continuous, since I'm running out of space. Okay, for the length of the package, same thing. We're measuring that, so it's a quantitative variable. But because you could have an infinite number of lengths, then I'm going to write this down as continuous. Okay, for food categories, meaning, is it a soup? Is it a vegetable? Is it a nut? Is it a dessert? There's those categories that's given in the problem. Because those fit into categories and it's not being described with a number, this is going to be a qualitative. So I'll label that as QL. Brand names, same thing. Brand names will create categories. So I'm going to label that as QL. Okay, part D, the data are the colors of the backpacks. Again, you want the same 5 students. One has a red backpack, 2 of the students have black, and 1 student has a green, and another student has a gray. Because colors create categories, anything that's red goes in this bucket, anything that's blue goes in this bucket. These are going to be categories, so this is going to be qualitative. The number of pairs of shoes you own. Now that's something that you count. So that's going to be quantitative. And because you're counting it, you can count the number of shoes you have. Even if you have a lot, it might take a while, but you can still count them, right? So this is discrete. The type of car you have, that's categorical. You're putting things into categories based on the kind of car you drive. So that's going to be qualitative. The distance, it is from your home to the nearest grocery store. Distance is something you measure, so that's quantitative. It's going to be a number. And because it's something you measure, it's a distance, it's a weight, something like that, where it has an infinite number of possibilities, that's going to be continuous. The type of calculator you use, that's putting things into categories based on your model calculator, so that's qualitative. The weights of sumo wrestlers. Weights are quantitative because we measure. And because it's a weight, it would be considered continuous. The number of correct answers on a quiz. This would be quantitative because we would count the number of correct answers on a quiz. But because we count it, it would be discrete. All right, once we collect the data, we're going to want to organize it. Now, here's some examples of some charts or graphs that you can use to organize your data, and these would all work for qualitative. Okay, the bar graph and the Pareto chart can actually work for qualitative and quantitative, but the pie chart is just qualitative. So it's important to be familiar with the different kinds of graphs that you can use to organize your data, because depending on the kind of data you have, certain kinds of graphs and charts and tables are going to work a little bit better Okay, so for a pie chart, I'm sure you've seen this before. Categories of the data are represented by the pieces of the pie in the circle. So when you look at a pie chart, it's a circle and then it's split up into different slices. Each of those slices represent a category. And the slice of the pie gets bigger as the percentage out of the whole gets bigger. So you want to make sure that your slices are proportional to the percent of the individuals in each of those categories. So let's write down to take notes. Let's say each category is represented by a slice of the pie and is proportional to the percent of individuals in the category. Okay, a bar chart is basically the same idea, but instead of having it in a circle with slices of pie, each bar is going to represent a category. And the height of the bars are proportional to the percent of individuals in the category. So the higher the percent, the higher the bar. So, and a bar chart will look like this. Like say I have 4 categories and each of those bars represents a category and the bar goes higher up as the percentage goes up. Okay, now a Pareto chart. This one you might not have heard of before. You may have seen it and not realized it. A Pareto chart is just a special case of a bar graph. It's a bar graph in which the bars are ordered from biggest to smallest. So let me put, it's a bar chart where each bar is organized left to right from tallest to shortest. And also keep in mind that the bars can go vertically or they can go horizontally. You could have bars that come out this way as well. Okay, so the Pareto chart, if I look at this example that I have up here, just a quick sketch of a bar graph, that would be my bar graph. If I wanted to use the same exact information to graph a Pareto chart, what would happen is you would still have the same heights of the bars, but we would just order the bars so that the biggest came first, then the next biggest, then the next biggest, and then the smallest. Okay, so now we're going to get into the topic of sampling. One thing that I can't stress enough, when you find your samples, you want to make sure that they have the same characteristics as the population that it's representing. So this is super, super important. And so another way to say this is one of our vocabulary words. We talked about a representative sample. Okay, that's what we mean by this. It's really important that we have a representative sample. If I wanted to find the average height of students on Rogue State College campus, and I go try to pick some students to measure and then find the average so that I can find out the average of the overall population on campus. So let's say when I decide to pick my sample, I'm at the basketball game and I'm like, okay, I'll just measure the heights of these basketball players. And you don't pick anybody else. You pick just the basketball players. You find all of their heights and then you average them together. What's going to end up happening is that is not a representative sample. So that way, when we go to find the average of those basketball players, it's not going to represent the average height of students on campus, because typically we know that basketball players are usually a lot taller than everybody else. So when I take the average, that average is going to be high. So it's not going to be a good representation of the average person at Rogue State College. So what I would want to do instead to make sure that I pick a representative sample, I would make sure that I pick people that are in sports, not in sports. I would make sure I pick males, I pick females, I pick different ages, I pick different people from different classes. You just want to get a whole bunch of different people, a good cross-section of that population. So then when you do take the average, it's going to make more sense and it's going to be more accurate. So that is why this is so important that you have a representative sample. Otherwise, all your research doesn't even matter if you're not even picking the sample correctly. So in general, when scientists do a study, they have an outline of steps they cover. Now, there might be organized differently in different books, but the same concept is there in every set of instructions. The first thing you want to do is identify what you want to study, identify the variables of interest, what data you're going to collect, and where you're going to collect it from. What is your population? So first, making those big identifications, those are really important to start off with. But once you figure out what data you need, the next step is to figure out and come up with a plan on how you are going to sample the data. How are you going to pick those people that you want to actually collect the data from to draw your conclusions? And this is where the different sampling methods come in. Depending on what you're doing and what the population is and what your goals are in the study, there's different ways to do it. Now, the examples we're going to go over in this lesson are the very basic ways to sample. There are many other ways out here, but these are the big key ones. Okay, so the first one, we're going to talk about random sampling. So random sampling is when you literally are choosing someone or something to be in your sample by randomly picking them. And usually that is with some kind of program or app that you can use to randomize something. So in general, you have a random sample, and that's just when you randomly pick someone or something for your sample. Now, a simple random sample is a little bit more specific. It is random. However, when you pick a simple random sample, you want to make sure that each individual in the population has an equal chance of getting picked. So that's the whole idea behind the randomized, okay? But then to make it a simple random sample, what you would add on is, and each sample has an equally likely chance of getting picked as well. So there's all different combinations of the way you can combine your population to pick your samples. And if each individual member in the population has an equal chance of getting picked, and each sample has an equal chance of getting picked, then that's what you call a simple random sample. Okay, now for a stratified sample. A stratified sample is when you take your population and you divide your population into groups, which is also called strata, which is why this is stratified sample. So when you break your population and split your population into groups, and each group is called strata, and then you randomly select the same number of individuals from each of those groups. So to give you a picture of what that would look like, imagine this box contains my whole entire population. And I split my population into 6 categories. So each category is one of those boxes. Okay? And so let's say I have all my population in here. So there's all these individuals in each of these groups that I split my population up into groups. Now, when I randomly pick from my groups, if I pick the same number randomly from each of these groups within the population, then that's called stratified. So let's say I pick 3 from each group. So in the first square, I would pick 3. I'm highlighting it in pink. So let's say I pick randomly these 3 in that group. And then in the next one, I pick these 3. And then in the next one, I pick these 3. So all of these pink dots would come out to form my sample. So that's stratified sample. Okay, cluster sample is when you divide the population into groups, but then you randomly select the whole group. So let's say again, I have an entire population and I split it up into 6 groups again. So in each of my groups, I have my individuals that are split up into categories. Okay, when you do cluster sampling, you pick the entire category. So I pick 2 categories. So I'm going to pick this whole category here. So all of these, everything that's in that category is going to go into my sample. And then I pick all of these. All of these are going to go in my sample. So the whole group, you randomly select a certain number of groups. This will form my sample. So in stratified sample and cluster sample, you're both breaking up the population into groups. The difference is with stratified sample, you pick a few, the same number from each one, for cluster, you pick that whole cluster to form your sample. You choose entire clusters. Okay, another way to sample is called systematic sampling. A systematic sample is when you randomly start selecting every nth piece. So let me write that down. So I imagine that my population is this entire conveyor belt running through this factory. And one of the workers, every third item, picks up off the conveyor belt and sticks it in a box, and that's the sample. So it's every nth individual or every nth object that you're choosing. Okay, the next kind of sampling is called convenience sampling. And this is not a random sample. Convenience sampling is when you're using results that are readily available for you. That makes it easy for you to pick your sample, but it might not necessarily be the best way to do it. So, for example, if I want to do a study on finding the most popular major in the state of Ohio at 2-year colleges, okay, and I should be picking samples from every 2-year college across Ohio so that we have a representative sample. And so instead of picking individuals from each college and putting them in the sample, because I work at Rogues, I just stand outside and I just grab people as they're walking by and I ask them what their major is and I record it. And let's say I do that for 50 students. And then I use that for my results. That's convenience sampling. It's not the best way to do it. I'm not really getting accurate results. It's not a representative sample, but I'm doing it that way because it's convenient. And unfortunately, that goes on quite a bit. Okay, so let me write that down. Convenience sampling would be involving results that are readily available. Okay, now we are also going to talk about when we're sampling, you can use with or without replacement. Okay, so when you are choosing members of your sample, you want to decide whether it's acceptable to have the same population member selected more than once. So if it's okay, depending on what you're trying to do, if it's okay, then the sampling process is said to be with replacement. So that means I can pick a member out of the population, put that member back into the population so that it has a chance of getting picked again. So with replacement, that's when it's acceptable to have the same member of the population picked more than once. Most of the time that probably won't be the case, but there are times where that is appropriate. Now, if it's without replacement, that means that you do not want that same person or that same object picked more than once. So let me color code this, and I'll put without replacement in pink. Okay, so without replacement means you don't want to pick that member, put them back into the population to have a chance of picking them again. Without replacement means you don't want the same person or object to get counted more than once. Okay, now we have sampling errors. And these are errors that make when you're sampling. And then we also have non-sampling errors. So when you have sampling errors, that's when your errors occur because of the actual process of sampling. So whatever it is that you're doing when you sample, that method you chose, or you're doing it inappropriately in some way, that would be a sampling error. So an error due to the process of sampling. Okay, and then the non-sampling errors, those don't occur because of the sampling process. Those are usually things like you counted incorrectly, or the machine that's weighing something isn't working, or you wrote something down in your notebook wrong. Those are things that are non-sampling errors, are not due to the sampling process. And those are typically human or machine errors. Now, the last term that we're going to cover is sampling bias. And this happens when you have a sample that is collected from a population where some members of the population are not as likely to be chosen as others. So when certain members of the population have like an edge to possibly have a better chance of getting into the sample. And so when this happens, there can be an incorrect conclusion drawn about the population that's being studied. So let's put down for sampling bias, it's when members of the population are not equally likely to be chosen for the sample. Okay, so we went through a bunch more terminology. Let's go through example 2 now. Let's see, it says, a study is done to determine the average tuition that San Jose State undergraduate students pay per semester. Each student in the following sample is asked how much tuition he or she has paid for the fall semester. We're going to look at each of these options in A, B, C, and D, and then we are going to choose based on our understanding of the terminology we just went over. We're going to label which sampling method is being used here. Okay, in part A, oh, it looks like there's a typo here. This should be B, this should be C, this should be D. Okay, it says a sample of 100 undergraduate San Jose State students is taken by organizing the students' names by classification, freshman, sophomore, junior, or senior, and then selecting 25 from each. So they took the population and they split it up into 4 groups: freshmen, sophomore, juniors, and seniors. Okay, and then they took 25 from each of these groups. This is stratified Okay, part B says a random number of generator is used to select a student from the alphabetical listing all undergraduate students in the fall semester. Starting with that student, every 50th student is chosen until 75 students are included in the sample. Now, because they're picking every 50th student, this would be systematic. It's every nth member. So again, think about that conveyor belt. When someone keeps picking off a certain number off that conveyor belt, that's systematic. Okay, part C. A completely random method is used to collect 75 students. Each undergraduate student in the fall semester has the same probability of being chosen at any stage of the sampling process. Okay, because these are literally being taken random and they're not split up into any groups or anything, that way all the population is considered one group that they're pulling from. Each sample also has the same likelihood of being picked. So this would be a simple random sample. Part D, the freshman, sophomore, junior, and senior years are numbered 1, 2, 3, and 4 respectively. A random number generator is used to pick 2 of those years. All students in those 2 years are in the sample. So this is the case where you split up into groups again. Here's my whole population split into groups based on freshman, sophomore, junior, senior, and it's labeled as year 1, year 2, year 3, year 4. A random number generator picked 2 of those categories, and then everybody in that category went into the sample. So this would be an example of cluster, because if I pick 2 and 4, everybody in that sample goes into the category, so this is cluster, which is opposed to up here where it's split into groups and then you pick just a few from each group. That's stratified. Okay, part E. An administrative assistant is asked to stand in front of the library one Wednesday and to ask for the first 100 undergraduate students he encounters what they paid for tuition for fall semester. Those 100 students are put in the sample. This is definitely convenience. Right? He's doing what's convenient and not necessarily the best way to pick the students that go in the sample. Okay, example 3, same thing. We're going to go through a few parts and determine the type of sampling method used. Okay, a soccer coach selects 6 players from a group of boys aged 8 to 10. 7 players picked from a group of boys 11 to 12, and 3 players from a group of boys aged 13 to 14 from a recreational soccer team. If I were to pick between the ones that we've talked about, I would say that this is considered stratified, because this is split into groups and then there's some taken from each group, although they should be picking the same number from each group, but I would say that that is the closest option given the options that I had to work with. Okay, part B. A pollster interviews all human resource personnel in 5 different high-tech companies. Well, if the population consists of different high-tech companies and they group them by company and then they pick 5 different high-tech companies and everybody from that company, this would be considered cluster, because they're splitting it up in groups by company and then choosing the entire company. Okay, part C. A high school educator research interviews 50 high school female teachers and 50 high school male teachers. This is definitely stratified. The groups are split into male and female teachers, and then 50 are picked from each group. Part D, a medical researcher interviews every third cancer patient from a list of cancer patients at a local hospital. This would be systematic because it's every nth person. In this case, it's every third person. In Part E, a high school counselor uses a computer to generate 50 random numbers and then pick students whose names correspond to the numbers. This is a simple random sample because every member in the group has an equal chance of being picked, and every sample has an equal chance of being picked. Okay, last example, or last part in this example, a student interviews classmates in his algebra class to determine how many pairs of jeans a student owns on the average. This is definitely convenient because the student only picks people from his high school algebra class in order to figure out how many pairs of jeans a student owns. He should make sure that he has a representative sample and make sure that he picks people throughout, depending on if he's doing this just at his school, but he should pick other people at his school, or if he's expanding that to local schools, he should make sure that he picks a variety of people. So this is definitely convenience. All right, now let's talk about variation. If we were going to sample two samples that represent the same population, okay, and if we used random sampling methods for the samples, they would not exactly be the same, but they should be pretty close if they were representative samples. If you are not doing the best job with collecting the sample and you don't get a representative sample, then you could have a lot more variation, which could cause errors in your conclusions. Okay, so in this example, example 4, it says, suppose ABC College has 10,000 part-time students, and we're considering that to be the population. We are interested in the average amount of money a part-time student spends on books in the fall term, and asking all 10,000 students is almost an impossible task. And that is absolutely true. So you're going to take some samples. And so suppose we take two different samples. Okay, so the first sample, we use convenience sampling, and we survey 10 students from the first term organic chemistry class. And many of these students are taking first term calculus in addition to organic chemistry. And so the amount of money they found that they spent on the book is as follows. And it lists a whole bunch of information there. Now, when you take a second sample, you use a list of senior citizens who take PE classes, and taking every fifth senior citizen on the list for a total of 10 senior citizens. And there's what they spend, 50, 40, 36, etc. So let's go through these questions. Do you think that either of these samples is a representative or is characteristic of the entire 10,000 part-time student population? Now, I would definitely have to say no to that because there were different ages picked, and they were picked in such a way that it wasn't a good cross-section of all of the students at that school. Most of the students in the school are a lot younger, and so you're picking just in that second sample, senior citizens. Additionally, when you're taking PE classes, you're not going to have expensive lab fees and expensive textbooks and expensive equipment, goggles, anything like that that you need to buy for the labs, or if you need an expensive graphing calculator for your calculus class. So it's most likely that that sample is going to have a much higher average cost for supplies. Versus if you're just taking an exercise class, you might have to buy an exercise mat or a couple new pairs of exercise shorts, but it's not going to be as much as having to purchase lab equipment, calculators, lab fees, big giant textbooks. That's a lot different. So definitely not a good representative sample. In part B, we kind of already talked about it. Is it wise to use the results to describe the entire population? These results are going to be very different because of the way the samples were picked. If you pick multiple samples, you should pick them the same way, and it should be a representative sample of the population. Okay, so when you have variation, it's going to be present in any set of data. However, if you make some errors, of course, the variation is going to be a lot bigger from sample to sample. Basically, just keep that in mind, that there will always be variation. But if the samples are picked well, meaning without bias, without making any sampling errors, making sure you're picking an appropriate sampling method. If all that goes well, the samples that are picked will be very similar. Okay, so that gets us through our content for section 1.2. And so looking ahead, once you have a set of data, you're going to need to be able to organize the data. And so understanding how to categorize the data, what kind of data it is, will help you determine what kind of graphs and charts to use. And so in the next section, we're going to start looking at some common ways that we can summarize and organize